Hi, my name is David with Rocket City Solar, and this is a demonstration of a simple solar power generation system. I have one 240 watt solar panel connected to my demonstration board that has a 40 amp MPPT charge controller and a small 400 watt modified sine wave inverter, one 12 volt battery, and some fuses to handle setting up for an off-grid solar setup. The way that I have it wired, the power comes from the back of the solar panel. Connections are wired into some small extension cords. These wires would be coming off of your roof in a normal configuration. I have them wired in coming into a disconnect that allows me to easily turn off the solar power. It comes positive and negative connecting into this disconnect. This disconnect jumps over to the top of this breaker, and also on the top of the breaker is a surge suppressor or surge arrestor. The surge arrestor is able to connect to ground, and if there is a surge, the surge arrestor would turn on and shunt all of that power to ground. In a normal configuration, the power would come into this breaker and go up into the charge controller, and the charge controller converts the power that's coming in from the solar panel and converts it to be right for your battery bank, whether that be 12 volt or 24 volt. The voltage of the panel doesn't really matter because the charge controller converts it. So as long as the voltage of the panel is greater than the voltage of your battery bank, you are fine. There's a little remote screen on here that tells you how much power is coming in from the solar panels. Right now it's somewhat overcast, so I am getting 24.3 volts at around 1 amp, and it's telling me about the voltage of my batteries. The power is coming into the charge controller and then leaves the charge controller and goes into the batteries, comes out of the batteries and goes up into the inverter, and the inverter converts that power to be, in this case, 5 volts on USB, or you can also connect a fan or some other device to your inverter to convert that power into 120 volts AC. I usually recommend that folks have a breaker in between your solar panels and your charge controller, and a breaker between the charge controller and your batteries. In this case, I've got this DC breaker here. You need to decide what battery voltage you will be running your system at. At 12 volts, a charge controller will provide a certain number of watts, and most charge controllers are able to provide twice that number of watts at 24 volts. For example, on this EP-Ever charge controller, at 12 volts you will get 520 watts, and if you're at 24 volts you will get 1040 watts. Having a greater battery voltage means that your panel voltage also needs to be greater. This 30 volt solar panel can come very close to providing the same number of volts as what is needed to charge a 24 volt battery, which most of those batteries would charge at around 28 volts. For a 24 volt battery, I would recommend setting your panels up in 2 series. I have a video that covers setting the difference between parallel and series, and if you're going to do 24 volts, you may want to check that video out. For this setup, we'd be able to add one more panel to charge this battery, as it is on 12 volts right now. If we were at 24 volts, we would be able to have as many as 4 of these panels connected to the system. You can use a Y branch cable, such as these, to connect multiple solar panels back to your main wire that's running back to your equipment. These can be connected directly to the back of the panels, and you plug them in between the panel and the wire that runs back to the charge controller. And so you could plug this in here, and this 4-way connector would allow you to have 4 panels or 4 sets of panels in series connected going back to your charge controller. I have a fan set up running and a meter plugged in so that I can see the power that's being consumed. So it's pulling 120 volts, and the fan is consuming 2.58 amps and 20 watts. So having a meter like this one enables you to be able to tell how much power is being consumed by appliances connected to your solar system.